Let's look at using the product rule in differentiation. This is done when you have two functions in X and you want to find you want to differentiate with respect to X, and it's particularly useful when it's very difficult to multiply out the functions and then differentiate. So you have y equals two functions in X. One is u and the other is v, and they multiply. What you do is this: dy by dx is equal to, you hold u as it is, don't make any changes, write down u, times, then differentiate v with respect to x, so it's dv by dx, plus, then you hold v as it is, write down v, then multiply by the derivative of u with respect to x, that's du by dx, right? Sometimes this is written as dy by dx is equal to u dv plus v du, because you know that it's by dx already. Now let's look at an example. Let's say, alright, let's erase this. We have limited space to work with. Suppose you have y equals, let's say, x plus 2 times x squared minus 3. Let's see what would be the case here. dy by dx is equal to, you hold the first one as it is. It doesn't matter whether you hold the first or second first, but out of habit, hold the first function here, which is, and by the way, let us make it x squared plus 2 and x cubed minus 3. Alright, let's do that. So y equals x squared plus 2 times x cubed minus 3. Let's use the product rule on it. You have x squared plus 2, then differentiate x cubed minus 3. What do you get? Well, you're going to get 3x squared, alright, plus, and then you hold x cubed minus 3 as it is, so it's x cubed minus 3 multiplied by differentiate x squared plus 2, you get 2x. Alright, so dy by dx equals, multiply it out now, 3x squared times x cubed, that's 3x to the 4th, plus 3 to 6x squared, plus 2x times x cubed would be 2x to the 4th, minus 2 3's 6x. Alright, so that's what you get. Now, come to think of it. Suppose we multiplied it out first and then differentiate. Would we get the same thing? Let's try that. We have y equal x squared plus 2 times x cubed minus 3. Suppose we multiply it out. We have x squared by x cubed, that's x to the 5, minus x squared by 3, that's 3x squared, plus 2 by x cubed, that's 2x cubed, minus 2 by 3, that's minus 6. Alright, now what we have is y equal, this is going to be 5x to the 4th minus, and then it's going to be 3 by, so, oh, dy by dx we should have, so we have x squared by x cubed x squared by negative 3, that's negative 3x squared. X 2x by x cubed, that's 2x cubed. And then 2 by negative 3, negative 6. dy by dx now is, so we have 5x to the fourth minus 2 3's 6x, 2 3 6x, right, plus 3 2's 6x squared, and this is gone. All right, this can be simplified somewhere. We didn't finish simplifying it. We see that there are 2x to the fourth, so 3x to the fourth plus 2x to the fourth is 5x to the fourth. And we have plus 6x squared minus 6x. Now this is 5x to the fourth minus 6x plus 6x squared. Alright, we can rewrite this and put them in order in terms of powers of x. So dy by dx is equal to 5x to the fourth plus 6x squared minus 6x. And then we see that we get the same thing in both situations, right? So in this case, we use the product rule, differentiated it, then we expanded it and then differentiated, and we get the same thing. Now luckily it wasn't too much work to expand the brackets, but in some cases it would be very inconvenient to expand the brackets, so you just have to stick with the product rule in those cases.